Hey,
Start this lesson on vectors with a clip from Despicable Me.
I'm applying for a new villain loan. Go by the name of Vector. It's a mathematical term. Quantity represented by an arrow with both direction and magnitude.
It's a mathematical
Vector!
quantity represented by an
Because
arrow
I'm committing
with both
crimes
direction
with
and
both
magnitude.
direction and magnitude. Oh, yeah!
Vector! That's me, because I'm committing crimes with both direction and magnitude. Oh, yeah!
All right, so hopefully you guys remember that from your childhood. But that is what a vector is, and that's what we're going to talk about today. So it is a directed line segment that involves both direction and magnitude. All right, so I have a diagram of a vector, and it kind of looks like a ray, but it technically doesn't keep going. So a ray has one endpoint and then keeps going in the other direction. But this vector is exactly this long. It doesn't keep going. The arrow just shows the direction that is pointing. Right, and this vector is in what's called standard form. And when a vector is in standard form, the initial point is at the origin. So where this vector begins is at the origin. A vector does not have to be in standard form. It could be shifted anywhere on the coordinate plane, but when a vector has the initial point at the origin, it's considered standard form. This particular vector has the terminal point at 2, 5. All right, so one form that we can write a vector in whenever it's graphed in standard form is called component form. And component form has what I call pointy parentheses. And the terminal point is where the vector ends, so it's where the arrow stops. And that is what's given in the component form. So when you see a vector written that way, this is telling you that the initial point is at the origin, the terminal point is at 2, 5 on the coordinate plane. Okay. There are two special vectors that are called unit vectors. They're special unit vectors, and one of them is called I, and in component form it is 1, 0, and then the other one is called J, and in component form it's 0, 1. So I want you guys to take a second and do a little sketch of those vectors. All right, so this red one is I. Right, and then this green one is J. So I just point straight to the right, J points straight up, and they're 1 unit long. All right, now the reason why I needed to talk to you guys about those special unit vectors is because there's another form that we can write vectors in, and it's called linear combination form. And linear combination form uses those vectors I and J to represent a longer vector that, or shorter, that is not just 1 unit long. And so if we take that vector, we started with vector V, that in component form was 2, 5. In linear combination form, it's going to be 2I plus 5J. Well, there's a ton of things where I'm not teaching you about vectors because of just the situation we're in this year. But one of the things that we're learning, or we would have learned, is multiplying a vector by a scalar and adding vectors. So basically, if we took vector I and multiplied it by 2, it would make it twice as long. And then if we took vector j and multiplied it by 5, it would make it 5 times as long. And then if we added those two together, we would end up with vector v. But you don't technically need to know that to do what we're going to do, or what I need to show you about component form. So it's basically take the vertical component, which is 2, and multiply it by I, the horizontal component, which is 5, and multiply it by j. All right, now the magnitude of a vector is basically the length of the vector. And the notation for magnitude is like, it kind of looks like double absolute values. Right, so to find a vector in component form or linear, or to find the magnitude, of a vector in component form or linear combination form, we basically use the Pythagorean theorem. So if we say that the vector in component form is the vector AB, so the horizontal component is A and the vertical component is B, if we wanted to find the magnitude, it's going to be the square root of A squared plus B squared. All right, so if we go back up and look at this vector that we've been talking about, the vector 2, 5, if we wanted to find the magnitude, we would do the square root of 2 squared plus 5 squared. Or it would just be the square root of 29. All right, let's go back up and label this v vector. So let's just say that, draw a little thing. This is the magnitude. It's really hard to see. All right, another thing that we need to talk about is the direction angle. And then the direction angle of a vector is the angle formed with the positive horizontal axis. All right, so if we go back up here, this is the direction angle. All right, so the direction angle tells you the direction the vector is going to point, and the magnitude tells you how long the vector is. All right. So if we wanted to find the direction angle of a vector, we're going to use the formula that the tangent of theta is equal to b over a. Where a is the horizontal component of the vector and b is the vertical component. Now, this can get a little messy if the vector is not in quadrant 1, and we'll kind of talk about that in a second. All right, so let's do a bunch of those things with the vector, a new vector v that has the components -4, 4. So the first part, we're just going to graph it. So what we would do is we would go to negative 4, 4. That's going to be the terminal point of your vector. So I drew kind of like an arrow there. We're going to start at the origin. There. That's vector V. Alright, the linear combination form, we just take the components and just translate them a little differently. So it would be the horizontal component and then multiply that by I, plus the vertical component and multiply that by J. Alright, and then if we wanted to find the magnitude of vector V, this is just the Pythagorean theorem. So it's going to be the square root of the horizontal component squared plus the vertical component squared. Alright, so that's going to be the square root of 32, or 4 square root of 2. Alright, and then if we wanted to find the direction angle, we're going to use that formula. The tangent of theta is equal to b over a. So in this case, b is 4, a is negative 4. So basically what we know is that the tangent of theta is negative 1. We also know by looking at our graph of the vector that theta is in quadrant 2. Alright, and then we're going to go ahead and use degrees for this. It seems like you see degrees with vectors more than you see radians, but you could see either one. So I do need you to know how to do this with degrees and with radians. But I think with the hand trick, you guys are a little more comfortable with radians. So anyway, if you have tangent of theta is 1 or negative 1, you actually do go to the hand trick. You do not go to the unit circle. It isn't an angle that's on the quadrant. It's one of your fingers. So just to recap, all right, those are the degree fingers for the hand trick. And then for tangent, if you guys remember, the tangent of theta is the square root of the bottom fingers over the square root of the top. So if we need to divide and get 1 or negative 1, then we want there to be the same number of bottom fingers as top fingers. And that only happens for the middle finger. So from your hand trick, you get 45 degrees. But you can tell by looking at the graph that that is not 45 degrees from the positive x-axis. So what is 45 degrees is this angle right here. So what we need to do is figure out what the purple angle is, not the blue. So we would take the 180 and we would subtract 45 degrees from it. And that's going to give us a theta of 135 degrees. So that would be your direction angle. Okay, so guys, the main thing that I've seen on the challenge exam, and this is the standard, is this very last part. Now we had to do the beginning to understand what we're doing at the end and know that I'd cut out a ton of things that you need to know with vectors for physics, for calculus too. So if you guys end up taking calculus next year, I may spend some time at the end of the year talking about vectors for those of you that are going to go on to calculus too, because there's a lot this year that you guys just don't get to learn, unfortunately. So anyway, if we can find that vector if we know the direction angle and we know the magnitude. And so the formula is going to be vector v equals the magnitude of that vector multiplied by the cosine of theta, comma, sine of theta. And this could be written in linear combination form also. All right, so multiplying the magnitude by the cosine of theta does give you the horizontal component. And that makes sense. If we made this into a right triangle, the cosine is going to give you this part right here. And the sine is going to give you that part right there. So hopefully it makes sense to you why this formula works. All right, so for example 2, we have a magnitude of 2 and then a direction angle of 300. So I would just fill those into my formula. All right. And then we need to think about where this vector is. So I'm going to kind of draw it at the bottom. This vector is in quadrant 4. And I know it's 2 units long. And I know this angle is 300 degrees. And I want to find that vector. Now 300 degrees is not on our hand to do the hand trick. So what we have to do is find the reference angle, which would be this one right here. And so hopefully you guys can see that that is 60 degrees. Because they would all add up. The 300 and the 60 would add up to give you 360 for a full rotation. Okay, and so then I can go to the hand trick. 60 degrees is this finger. When I want to find the cosine of 60 degrees, I would do the square root of the top over 2. Now, I'm not necessarily finding this cosine of 60 degrees. I'm technically finding the cosine of 300 degrees. So in quadrant 4, cosine is positive. So the cosine of 300 should be 1 over 2. All right. The sine, if you're going to do the hand trick, is the square root of the bottom over 2. Now we're finding the sine of 300 degrees, and sine in quadrant 4 is negative. And we would do the square root of the bottom fingers over 2. All right, and then I would think that on the exam they would have you all multiply this out. So you would just, you do need to know this, and we didn't talk about this, but to multiply a vector by a scalar, you basically just multiply each component by it or distribute it. So that's going to be 1, the negative square root of 3. In a linear combination, that would be I minus the square root of 3j. So you could see it either way on the exam. And then just take a second to make sure that makes sense. That if I graph this vector, it would be in quadrant 4. The horizontal is positive, the vertical is negative. So we're in pretty good shape. All right, so let's do the same thing with B. To set up the formula, we're going to say that vector V is going to be equal to the magnitude, and then times, and then in your components, it's going to be cosine of 225 degrees, comma, sine of 225 degrees. All right, so I'm going to scroll down a little bit to the hand trick. 45 degrees is this finger. I do know that the reference angle for 225 is 45. If you didn't know that, you would want to graph it. You probably would want to graph it anyway. Oh, yeah. 225 is in quadrant 3. All right, so remember, we always kind of need to figure out the reference angle. So the closest angle to the x-axis is 45 degrees. Okay. All right, so when we do the cosine, we're going to do the square root of the top fingers over 2, which is going to be the square root of 2 over 2. And I know that the cosine in quadrant 3 is negative. All right, for the sine, we're going to do the square root of the bottom fingers over 2, which is square root of 2 over 2. And again, the sine is negative in quadrant 3. All right, and then to multiply that, there's not really anything we could do on the last one because it was an even number. We can multiply it by half. But here it's odd, so I would think the answer would be something like 7 square root of 2 over 2 for the horizontal component, and the same thing for the vertical. All right, then if you wanted to write it in linear combination form, it would just be that same thing, but with I. We'll do minus since it's negative. And then J. Right. And both the components are negative, which is good because that's what's supposed to happen in quadrant 3. Okay, guys, so I have the problems I want you to do at the bottom of this. If you didn't print it, it's fine. Just write these out on a piece of paper. I know a lot of you don't have printer or don't have